Welcome. In this lecture, we'll be reviewing how delegates work and see how delegates play a crucial role to managing multiplayer game sessions. We'll then go over the steps to creating our own game session, then print some text to the screen to verify that our game session was created. A delegate can be thought of as an object that holds a reference to a function. Unreal Engine delegates are capable of having functions bound to them, then broadcasting a signal that each bound function will receive and execute in response to the broadcast. We typically make functions, usually referred to as callback functions or callbacks, and bind them to delegates. When a certain event in the game happens, the delegate is fired or broadcast, and any functions bound to that delegate will be called in response. The online session interface makes use of delegates. This is because things like creating and joining game sessions requires information to be sent across the internet, which takes time depending on your connection speed. So if we access the session interface and call its create session function, information will be sent to the platform, in this case Steam, which will result in the game session being created, and then Steam must send information back to our machine to let us know that the action of creating a session has been completed. The session interface makes use of delegates to do this. The session interface defines a set of delegate types, then holds a delegate list that it iterates through, firing off events when appropriate. What we will do on our character is create a new object of one of these delegate types, which we will bind a callback function to, and then add our delegate to the session interface's delegate list. We'll first create a variable for one of these delegates of type f_onCreateSessionCompleteDelegate, and we'll have this variable of this delegate type on our character class for now. We'll also create a callback function on our character class called onCreateSessionComplete and bind it to our delegate variable. We'll then access the session interface and add our delegate object to its delegate list. Then, we'll call the create session function on the session interface class, which will connect to Steam and create our game session. Steam will then send a signal back to our session interface, and the session interface will iterate through its delegate list, firing off any delegates that we've added to this list. This will result in our callback function being called, and our callback will also receive information about the session that was just created. We can use this information to print an on-screen debug message to verify that our session was just created successfully. So let's get started creating this system. The first thing we're going to need to do is create our delegate variable and make a callback function. Now here's my menu system project, and here's my Visual Studio project. Now first, I'm going to make a blueprint callable function that we can call from blueprints in response to pressing a key on the keyboard. Now we can make a protected section, and I'll stick this function in the protected section. It's going to be a void function, and I'm going to call it createGameSession. And I'll make this a U function marked as blueprint callable. And we'll place all our session creating logic here in this function. So I'm going to make a body for this function. And here in the function body, I'll simply add a comment and say called when pressing the 1 key. In here is where we can access the online interface and call create session. Now we're going to be creating a delegate. So we can create a private section here and declare a new variable of this delegate type. Now the delegate type we're interested in is f_onCreateSessionCompleteDelegate. Now we can simply call this delegate createSessionCompleteDelegate. Now, if we attempt to compile this code, we'll get the same error that we got earlier when we tried to make the online session interface pointer, and that's because we're not including the online session interface header here. Now, f_onCreateSessionCompleteDelegate is another type def, and we can jump through the same hoops as we did before to avoid having to include the online session interface header here. But rather than getting into the habit of reconstructing these type defs on our own, I'd like to simply be able to use these type defs as they were created for our convenience. So I'm simply going to include the online session interface header here in menusystemCharacter.h. So here's menusystemCharacter.cpp. I'm going to take this include for online session interface.h and cut it and paste it here at the top of menu system character.h. Now remember, if we're including headers here in the character's header file, they have to be above the .generated.h header. Now that I have online session interface.h here in the character's header file, I can use this typedef for the onCreate session complete delegate. So if I go ahead and compile, I get a successful compile, so IntelliSense should catch up and get rid of that red squiggly there. And since we're doing this for create session complete delegate, we might as well use the typedef for this type rather than forward declaring iOnlineSession here. And the typedef for this type, remember, is iOnlineSession PTR, or online session pointer. So this will make our code a little bit easier to read and easier to write, as well as we're taking advantage of these typedefs created for us. So we now have this onCreateSessionComplete delegate variable called createSessionCompleteDelegate. This will be the delegate that we add to the session interface's delegate list. Now, we've created a delegate variable, and we're also going to need to bind a callback function to this. This will be the callback that will be called in response to successfully creating a game session. So we're going to create a void function, and this will be called onCreateSessionComplete. Now, this function will be bound to this delegate, which means it needs a particular signature. Its input parameters and return type have to be correct because the onCreateSessionComplete delegate type is only designed to have certain types of functions bound to it, and those functions have to take input parameters of type fName, and this input is called sessionName, as well as a bool called bWasSuccessful. Now, the reason I know this is because I've taken a look at onCreateSessionCompleteDelegate. If I right-click on it and peek the definition in onlineSessionInterface.h, now we see that the onCreateSessionCompleteDelegate type is declared here. Unreal Engine delegates are declared using these special macros that will result in all the behind-the-scenes code necessary to create this delegate. And for multicast delegates with two params, the types for the input parameters for functions that can be bound to this delegate type are listed here, an fName and a bool. The comments even tell us what these input parameters are for. The first is for the session name, and the second is to determine whether or not the session was created successfully. So this is not something we need to dig in too deeply. We just need to understand that the delegate exists, and a function that takes an fName and a bool can be bound to this delegate type. So let's close out of this. And now we have a callback function, so we can create a definition for this function. So here's our callback. So now that we created a delegate variable and a callback function, it's time to actually bind the callback to the delegate. Now we have this createSessionCompleteDelegate, and it's just a variable of this type, but we actually need to construct the delegate, and we can do that here in the character's constructor. I'm going to go all the way up to the top and add a colon here so we can use the memberInitializerList method of initializing variables. Now, just as a review, if you're not familiar with how to do that, you would take the variable name, such as base turn rate, and use parentheses and add the value inside the parentheses that you'd like to initialize the variable to. We're going to initialize our variable createSessionCompleteDelegate. So we'll say createSessionCompleteDelegate and use parentheses and initialize it with whatever we place inside the parentheses here. Now, there are different types of delegates built into Unreal Engine. This particular type of delegate can be constructed using a static function that exists on this class. And that function can be called here in the parentheses. So we're going to use onCreateSessionCompleteDelegate with a double colon followed by the function that will create a delegate, and that is createUObject. So createUObject will construct a new onCreateSessionCompleteDelegate object, and it takes some input parameters, including the callback function that we can bind to it. So what we're doing here is constructing the delegate object, and in that createUObject function, we're going to pass in the callback function to bind to it. So we're essentially creating the delegate and binding a function to it all in one go. Now, the first input parameter is a pointer of type userClass, and we're going to pass in this as this is the class that's using this delegate. And next, we need to pass in the function that we would like to bind to our delegate. Now, it must be the address of the function, so we have to use the address of operator, and we can simply pass in the fully qualified name of the function. That means we'll type in a menu system character, :, and the name of our callback, which is on create session complete. So we're calling create uObject, a function on this delegate class, and we're passing in the user object and the function we're binding to this delegate. Now, Unreal Engine does have a built-in shortcut when we'd like to pass in a fully qualified function name, and that is this class. If we use the this class type def, you'll see that it's a type def for this particular class we're in. This is kind of a convenience that we can use if we don't want to type in the whole menu system character class name. So we've now initialized our create session complete delegate variable with an actual object of this type, and we've simultaneously passed in the callback function, effectively binding it to our delegate variable. So now that we've created a delegate and a callback function and bound the callback to the delegate, it's now time to call the create session function on the session interface. So we have a blueprint callable function that we've created called create game session, and we plan on calling this from blueprints when we press the 1 key. Now, going back to our character's header file, we see that we have this online session interface pointer that we've initialized in the character constructor. I'll just quickly scroll back up to remind you that we got that interface from the online subsystem using get session interface. So online session interface should hold the session interface, but in C++, as you know, it's always good to check to make sure pointers are valid before using them. We're going to use an if check, and we're going to use the online session interface pointer that we have. And being a smart pointer of type tshared pointer, the way we check to see if it's valid is by using the function isValid. This is a function that belongs to the tshared pointer wrapper. That's what this online session interface is, after all. Now, we're checking to see if it's valid, but what I'd like to do is use the negation operator here to check to see if isValid returns false. So if we reach the inside of this if check, then our online session interface is indeed not valid, and in this case, we'll simply return. Now, if we make it past this if check, then the session interface is indeed valid. Now, once we start creating sessions, we'll quickly find that if we've already created a session, we can't create another one without first destroying the existing session, which means the first thing we're going to do is check to see if a session already exists. We'll do that using our online session interface pointer and calling the function getNamedSession. Now, this takes an fname because once we start creating sessions, we'll be giving them session names. Now, we could create an fname variable for our session name, but we're always going to be using the same session name. There exists a global variable called name_game_session. If we always use this name game session, then we'll always be checking to see if a session with this name exists. Now, getNamedSession returns an object of type fNamedOnlineSession. Now, we're going to store this in a variable called existingSession, and I'll simply use auto to make it easier for declaring this local variable here. And what we're going to do is check to see if this existing session is not a null pointer. So we'll say if existing session is not null pointer, then in that case, we'll simply destroy the session. So we're going to call online session interface destroy session. And to call destroy session, we simply pass in the name of the session, which will be name game session. So essentially what we've done so far is check to make sure that the online session interface is valid. If it's not, we'll simply return out of this function. And then we'll get the existing session, if one exists, with this name, And if that existing session is not a null pointer, we'll simply destroy the current session with this name. That way, we'll be able to create a new session. Now, we're ready to create a new session, and that is going to involve setting some session settings. Now, here's the documentation page for F-Online session settings. This is the type for session settings when creating a new session. Here's the include. It's online session settings.h, so we'll go ahead and copy that. And you can scroll down and see all of the different settings that exist on this type. We'll be setting just a few of them, and we'll learn more about them as we continue on in this course. So here in our .cpp file, I'm going to include online session settings.h so we can create a new object of type F-Online session settings. Now, we need to use the tshared pointer type as a wrapper for our F-Online session settings variable. For now, we'll just create a local variable here. It's going to be tshared pointer F-Online session settings, and we'll call these session settings. Now, this is just an uninitialized pointer. In order to create a new object of this type, we need to construct one. Now, the way to initialize a new tshared pointer is by the use of the makeShareable function. And inside makeShareable, we use the new keyword followed by the constructor of the class we're creating. And this is going to be an F-Online session settings object. So we're calling the constructor for this type, and makeShareable will wrap this up in a tshared pointer. Now, the F-Online session settings class has several variables that we can use for our session settings. We're not going to get into those just yet. We're simply going to use this to call create session. And we'll do that using our online session interface pointer. So we'll say online session interface, and we're going to simply call create session. Now, create session takes a couple of arguments. It takes an F-unique net ID called hosting player ID, and then it takes a session name, and finally, an F-Online session settings object called new session settings. So first we need this F-unique net ID. Now, the way to get that is by getting the world's first local player. We're going to create a const uLocalPlayer pointer called localPlayer, and we can get the first local player from its player controller using getWorld getFirstLocalPlayer from controller. This returns a uLocalPlayer, and the uLocalPlayer allows us to get that unique net ID. So we'll pass that in here. It's going to be localPlayer, and we're going to call the function on the uLocalPlayer class called getPreferredUniqueNetID. Now, this returns the type FUniqueNetID REPL. That's short for replication. If we peek the definition, we'll see that this is that type. And of course, if we peek the definition of this type, we can then see the definition of this type. But we don't really need to get into that. We can see, however, that it is of type FUniqueNetID wrapper. And this wrapper does overload the asterisk operator, which says dereference operator returns a reference to the FUniqueNetID. So we do need to use the dereference operator here. So going back to our character class, the value returned by this function needs to be dereferenced, so we're going to place an asterisk right here at the beginning. Now, our next input parameter is the session name, and we're going to use, once again, name game session. And the third parameter is going to be our session settings. So we're going to type session settings. And if we look again at the input parameter list, we see that we need our session settings passed in, but we're passing in a pointer. It's not expecting a pointer, so we also need to dereference our session settings pointer as well. So we're going to use the dereference operator there, and that will get rid of all our errors. Now, we're calling create session, and we have a delegate to respond to it, but we still haven't added that delegate to the session interface's delegate list. So we're going to do that before we create the game session. So we're going to take online session interface, and in order to add our delegate to its delegate list, we're going to call add on create session complete delegate underscore handle. Now we'll see that we can pass in our delegate here. So we're going to pass in our create session complete delegate. So after we've done this, the online session interface will now have our delegate added to its delegate list. And once we've created a session, then our callback function, which we've bound to this delegate, will in fact be called. That callback is right here on create session complete. This is where we will verify that our session has indeed been created. So now that we've called create session, it's time to verify that our session has been created. And we'll do that in our callback function where we can print the session name. So here in onCreateSessionComplete, we have some information passed in once the onCreateSessionComplete delegate was broadcast. Our callback functions will be receiving information in response to the broadcast. The first thing we'll check is this Boolean B was successful. This will be true if we've successfully created a session. So we can make an if check and say if B was successful. And we'll also have an else case just so we can know if this Boolean is false. If it is false, we'll add an on-screen debug message. So we'll say if gengine add on-screen debug message, and we'll use -1. For time to display, we'll use 15.f, and for color, we'll use an f color, and I'll go ahead and use red just to catch our attention in the case that B was successful was false. And for our message, we'll simply make an f string and initialize this with failed to create session. That way, if things go wrong and we can't create a session successfully, we'll see that on the screen. Now, I'm going to copy this and paste it right here in the case that B was successful is true. And we'll go ahead and use blue for the color in this case. Now, for the string, I'd like to use printf again. So I'm going to say printf and use a text macro for the string. And we'll say created session and use that %s format specifier. And we're going to use that session name. So we need to use session name, but because this session name is an f name, we're going to convert it to a string using toString and then convert this to a C-style string with the asterisk operator. So now if we successfully create a session, we will print the session name with our formatted string in blue. And if we fail to create a session, we will print this message in red. Okay, so we've created a blueprint callable function. Let's go to our character blueprint third-person character and open the full blueprint editor here. I'd like to call that blueprint callable function in response to pressing the 1 key. So I'm going to right-click, type keyboard, and select the 1 key, and off of the 1 key, I'm going to type create game session. This is our blueprint callable function. So I'm going to compile and save this. So we're now set up and ready to test this. Just to recap, we created a blueprint callable function. This will be called when we press the 1 key. We also made a delegate and a callback. And in our characters constructor, all the way at the top, we created this delegate using createUObject, a function on the onCreateSessionCompleteDelegate class. This createUObject function constructed a new delegate and also took in the address of our callback function, effectively binding our callback to the delegate. Then, in our blueprint callable function createGameSession, we first checked to see if the online session interface was valid. If not, we simply returned. We then checked to see if a session already existed, and if that existing session was not null, we called destroySession. Now, getNamedSession and destroySession take a session name, and we're simply hard-coding this global variable called nameGameSession. Now, after this, we added our delegate to the session interface's delegate list using this function add-onCreateSessionCompleteDelegate_handle. We're going to learn very shortly what this handle here means. Now, after that, we created a new session settings wrapped in a tshared pointer, which we had to use makeShareable in order to initialize it with a new onlineSessionSettings object. This is the session settings that we had to pass in to createSession. CreateSession also required an f-unique netID, which we got from our world's local player. We called getWorld, and from the world, we called getFirstLocalPlayerFromController. And this is pretty self-explanatory. The world has access to all the player controllers in the world, and it's simply got the first local player, and this function returns a uLocalPlayer pointer, and uLocalPlayer has the getPreferredUniqueNetID function. And of course, we had to dereference that using the asterisk at the beginning, and we passed in the netID, the game session name, as well as the session settings. Of course, our session settings is wrapped in a tshared pointer, so we had to dereference that as well. So now we're finally calling create session. And if all goes well, this will result in creating a game session. And once that's finished, our callback will be called, in which case we can print the name of that session. And if something goes wrong and B was successful returns false, then we'll print a red message to the screen and we'll know that something went wrong. Now, before we test this out, we're going to need to set some session settings. Now, the F-Online Session Settings class has several variables. We're going to use a few of them to configure our session that we're about to create. So we're going to say session settings, and the first setting we're going to set is B is LAN match. We're going to set this to false because we're not creating a LAN match. We actually want to connect over the internet. Now, the session settings also has a set number of connections which determines how many players can connect to the game. It's called num public connections. And we're going to set this to a value such as 4. That way, once we program the ability to join the session, we can have a total of 4 players in the game. Now, the session settings also has a setting called be allow join in progress. This means if a session is running, other players can join while that session is running. We're going to set that to true. Now, the next session setting that we need to set is called be allow join via presence. When Steam sets up game sessions, it uses something called presence. It doesn't just connect any player from around the world to any other player. It has regions, and it searches for sessions going on in your region of the world. Now, we need to use presence in order for our connection to work, so we're going to set this setting to true. Our next session setting is called be should advertise, and this allows Steam to advertise the session so other players can find and join that session. We're going to set that to true as well. And finally, our last session setting that we're going to set is called be uses presence, and this will allow us to use presence in order to find sessions going on in our region of the world. So we're going to set this to true as well. So let's go ahead and compile this now. And now we've set all of our session settings that we're passing in to create session. So once we call this, the session will be created using these settings. So I'm going to challenge you to test this out. Go ahead and package the game. Make sure you start Steam because Steam has to be running in the background in order to connect to Steam. Then playtest the game and see what we get printed out to the screen. Did you in fact create a game session? Pause the video and test this out now. Okay, so we're ready to test out our game. I'm going to first save everything, and I'm going to go to Platforms, Windows, and Package Project. Now, there's still a build here from the last time we packaged. I'm simply going to delete that, and here in my build folder, I'm going to click Select Folder, and now we're packaging the game. Okay, so now that packaging is complete, I can open that build folder here in my project. And in the build folder, here's the Windows folder, and there's my menusystem.exe. I'm going to double-click this to launch the game. Now, I see at the top left, Found Subsystem Steam. So we're connected to Steam, and we're ready to try creating a session. I'm going to hit the 1 key, and now I see Created Session Game Session. That's the name of the session. That's because we used that global variable name Game Session. The string value of that is literally Game Session. So we've successfully created a session. Our next steps are to implement functionality for joining the session from another machine. So in our next video, we'll continue with this by creating a lobby level, and we're going to travel to this level once we've created a session. And there we can wait for other players to join. We're also going to set up a function for joining a session. That way we can package up our project and send it over to another machine that can then launch the project and join our running game session over the internet. So, in summary, we've reviewed delegates and how these play a crucial role to managing online sessions in Unreal Engine. We created an f_onCreate session complete delegate as well as a callback function that we then bound to this delegate. And we added this delegate to the session interface's delegate list. And finally, we called create session, which resulted in creating a session, and once this action was complete, our callback was fired off in response since we bound it to our onCreate session complete delegate that was added to the session interface's delegate list. Excellent job. We've already come a long way in setting up this system for managing game sessions. We'll start to set up the ability to join sessions in the next video. I'll see you soon. Now, if you're having any issues creating a session, particularly if you're on Unreal Engine Preview 2 or Unreal Engine 5.0, the latest official release, I've had some students unable to create a session without this line here in defaultengine.ini. Now, you might see something like this if you copy these lines from the Unreal Engine documentation. If you can't create a session, just replace these two lines with this line, binit server on client equals true under online subsystem Steam. If you have this, then you should be able to create sessions. So go ahead and save this. Make sure you regenerate project files for your project and give it a try. Now, just a quick update, guys. Some people are getting a crash if they create a C++ project with the third-person template or the third-person character. Now, this is a known bug in Unreal Engine 5 that still needs to be ironed out, and it's related to the third-person character's animation blueprint, so there are a couple of ways to get around this. The first is that you can find that third-person blueprint. So opening the third-person character here, we can select the mesh, and for the animation class, anim class, we can set this to none. Now, of course, that means that the character is going to T-pose, but if you're only concerned with checking the connection, this is fine. Now, I know that just being in the T-pose sucks, so if you want to test multiplayer with a replicated character, another alternative is to simply use the old third-person mannequin. So you can take some other project if you have the mannequin there, or create an older Unreal 4 project with a third-person character. However you get it, you can get that mannequin, and you can migrate that character blueprint right on over. In fact, you can migrate any character blueprint straight on over to your project and use that. So apologies for this. This is one of those instabilities with Unreal Engine 5 that still needs to be ironed out. But if you just want to test the connection, make sure that networking is working, you can simply set that anim class to none and at least get it started. Now, this isn't going to affect the course, as we are going to create our own custom character using our own custom mesh. So this is just one of those hiccups that will likely change as soon as Unreal Engine fixes that bug. Now, some students are getting this error message saying that the SDK for Windows is not initialized properly, which is needed to generate data. Now, if you get that message when you're trying to package, the solution is simple. You need to make sure that you have the latest SDK, as well as .NET Core 3.1 Runtime LTS, which you can make sure that you have by updating Visual Studio in your Visual Studio installer. So opening your Visual Studio installer, and whichever version that you're using, you can modify it and go to individual components and make sure that you have .NET Core 3.1 Runtime LTS. So these are some of those things that are not that obvious, but with a new release of Unreal Engine, we're using newer technology. We need to make sure that we have all the components that we need. So it's a great idea to update your Visual Studio and make sure that you have that component there.